graphs. So to look at graphs, it's very helpful to think about them as a scanned group of numbers. So like when I scan across here, and I were to think about this, beep, 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 those inputs produce the domain. Notice here we have proof that it's not a function because I have a vertical line touching two different points, meaning two different outputs. And the range would go from the bottom to the top, so beep, 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 beep. Now, in order to make that make the most sense, I think it's very vital to label these points. Notice that this graph goes by 2, so this looks like -3, but it's actually -6, okay, comma 4. And this point is -2, comma 0. This point is -6, comma, sorry, -2, comma 6. Sorry, it's +2, 6. 2, -6 is what I'm trying to say. This point is 4, 0. This point is 2, 6. So now that I know that, and I combine that idea that I had about using this line as a way to determine the domain, beep, 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 those three numbers are the domain. Keep in mind that this right here clearly determines that it's not a function. So to answer the question in its entirety, we're going to say no, that's not a function. We're then going to say that the domain is -6, -2, 2. It occurs twice, but we're only going to put it in there once. And the range is -6, 0. It occurs twice, but only put it in once. 4, and then 6. All right, so what happens when we have a function more like this that actually has connected values? Well, that beeping thing becomes very important. If I look at this domain, first of all, clearly not a function. There are an infinite amount of places where there are two outputs. But if I go through here, if I were to beep, instead of being like this, beep, 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 it beeps the whole time. It starts here, beep, and it beeps the entire time. So it starts beeping at -3 and it ends at 3. And the range starts beeping at at 1 and stops at 3. So it would be like this, nothing, 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 beep. Okay, so the way we would write that out is, first of all, we're going to say no for the function. It is not a function. And the domain, as we said, it starts at -3, and then it stops at 3, and the range starts at 1 and stops at 3. And because it touches that point, we're going to use that solid bracket as opposed to an open or parentheses, which would be if there were an open circle. My next example will have an open circle. So again, what that's saying, again, if I look at the domain, beep starts at -3, touches -3, and then beeps the whole way to 3. Now this one starts at 1 and stops at 3. All right, let's take a look at the next example and see if we can see when we would use a parentheses as opposed to a bracket. So looking here, we have a graph of, starts and stops here. In the domain, first of all, let's see if it's a function. I don't ever see this line touching it more than one time. Every time we have this line, the intersection is intersecting once. So this is a yes. And looking here, it actually doesn't include -3. So it actually would not start beeping here. It would just be nothing. And then right after this, beep, stops right there at 3. So this one, again, what it would become is it would be a yes. And it would start at -3, but not include it because it's open. So open is a parentheses. Another way of thinking about it is an open circle kind of looks like two parentheses together. So one way that you can think about it. And then it ends at 3, but because it has a solid circle, it touches it, and I denote that with the bracket. The range would be to start here at the bottom, and I got to go right there. Remember, that's not 3. The range for that, again, if you need to, it really helps to label points in algebra so that you don't get confused. That point is 3, 0. So if I talk about the range here, I'm talking about 0 not 3, because I need the output. And then it actually does not stop here, right? That's not the end of the graph. If I start here, beep, it doesn't stop there. It actually goes all the way up to here. So beep, right there. And so the top of that graph, if I were to label its point, because remember, sometimes kids will identify the input, that point is the point 0, 5. So I want the output, since I'm talking about the range, and so it does go to 5. And in fact, it includes this value because it is touching it. I always tell my students, if you don't see an open circle, it's a solid circle. So negative 0 to 5 for the range. So this one I left out because I want to show you what could happen. I left out what it is. So this is a function. You can see that it only hits once. And if I put a solid circle there, watch this. If I put a solid circle in that point right there, then I would have a bracket. So I would come down here and I would put a bracket at this is by 2, so 2, 4, 6, 8. I would put a bracket at -8. However, if I used an open circle here, I'll just use a different color. If I used an open circle instead, right there, then I would use a parentheses and a -8. That's basically the difference. However, they would end at the same spot, and this actually goes on, doesn't stop here. I mean, think about this. If this were to keep going, beep, it'd actually be way over here. So both of these go to infinity. So I would put comma infinity for this one, and then the open circle one that doesn't change anything that's happening on the other side, that would also go to infinity. The range is kind of interesting. I want you to think about this. The range actually starts way down here. It's beeping because that arrow would eventually get down all the way to here. And it actually starts the initial concept beeping. So beep, and it would keep going from here, and then it would stop its range, not here, but there. So beep to that point. And again, it really does help, especially trying to make sure you get a good grade, make sure you don't make careless mistakes, to understand that point is 0. Remember, I'm going by 2s here, so 6. So the way we would denote that, by the way, this was a function, so yes. The way we would denote that is negative infinity, because we started at the bottom, and it goes up to 6 with a solid touching point right there. So in general, if your arrow goes this way, you would have negative infinity. And if your arrow goes that way, you'd have infinity in the domain. So domain from left to right is negative infinity to infinity. And the range would start at negative infinity, and if you got to the top without stopping, that would be positive. So maybe that'll help you understand how I got this a little better. I started here, negative infinity, beep, and I stopped at 6. And then here, I started at -8, and I went to infinity. If you have to label the axes that way, that may help. So my last